Hello guys, this is Wasim from Edureka and I welcome you all to this session where I'll be talking about operators in Python. So without wasting any more time, let's look at the agenda for this session. So I'll be starting with what exactly is an operator in Python and why are we using operators in Python. Moving further, we will discuss various types of operators that we have in Python. For example, arithmetic operator, assignment operators, then we have comparison operators, etc. I will also be running a few examples in Jupyter Notebook for better understanding. I hope you guys are clear with the agenda. So let's try to understand what exactly is an operator. An operator is used to perform operations between two values or variables. Now we can call the operators as constructs or special symbols that are used to manipulate the values of the operands. Now you must be wondering what is an operand. So the value that we use in an operation are known as operands. These operands can be variables or any data type that we have in Python. So let's take an example here. So we have two operands, operand 1 and operand 2. Now when I add an operator between them, we can get the result according to the type of operator that we are using here. So before moving on to the types of operator that we have in Python, let's briefly discuss variables and data types in Python. The purpose of discussing variables and data types is to get an idea of what exactly is variable and data types. Because while explaining the different types of operators, we are going to use these variables and data types as well. So variables are nothing but the memory locations where we store a value. And these values we may or may not change in the future. According to the properties they possess, there are 6 data types in Python, namely numbers, string, list, dictionary, tuple, and a set. Now let's take it up to Jupyter Notebook to understand these data types briefly. Talking about numbers or numerical data types, they mainly hold the numerical values. For example, a variable, let's say x, is going to hold the value that is 10. So this is going to be a number or a numerical data type. Now in numerical data types also, we have 4 types of data types. First of all, we have integer, which is going to hold the whole numbers. Then we have float data type, which is used for declaring decimal point values. And then we have complex numbers, which are used to declare imaginary part values. For example, we use the j as imaginary part over here. And then we have a Boolean data type, which is used for categorical output, that is true or false. So when I print the Boolean number over here, it is going to give me the value as true or false. So this was all about numbers. Talking about strings now, strings are used to represent the characters or alphabets. We can use the single or double quotes to declare a string in Python. Also, strings are immutable in nature, which means you cannot change a string once you have declared. And to access a value in a string, you can use the index values over here. So when I use the index number 2, it is going to give me the value at the index number 2 here. So this was all about strings, guys. Talking about list, list is a sequence which is ordered and changeable, which means you can change values in a list. To declare a list, you have to give a name for your list. And we use the square brackets to declare a list in Python. List is also indexed just like a string, so we can use the indexes to access the values from a list. And we can store different values in a list as well. For example, I can use numbers over here, give duplicate values as well, and I can use strings over here as well. So when I print my list, it is going to give me the value like this. Now talking about dictionary, dictionary is a sequence just like a list, but we use the key value pair in a dictionary. I'll show you guys. To declare a dictionary, we use the curly brackets. Now I'm going to give the key value pairs over here. So let's say this is my key 1. I'll give a semicolon. Now I'll give the value over here. I'll give one more key value. Let's say key number 2. So when I print my dictionary over here, I'll get the values like this. Now since it has a key value pair, it is not indexed, which is why we can use the unique key values as an index to access the values in a dictionary. So what I'm going to do is I'm going to write the index number as my key value, and it is going to fetch me the value at that particular key. So let's talk about set, guys. A set is also a sequence which is unordered and not indexed, which means you cannot access the values using the index number. So I'll just write a few values over here, some duplicate values as well. So when I print my set over here, it is going to give me the values like I have mentioned over here, and it is not going to hold any duplicate values in a set. Also, we use the curly brackets to declare a set. Now talking about tuple, Tuple is immutable in nature, which means you cannot change a value in a tuple once you have declared. And we use the round brackets to declare a tuple in Python. So I can give as many values as I want over here, even the duplicate values as well. So when I print my tuple over here, I'm going to get these values that I have declared in the tuple. So the difference between a tuple and a set is not indexed, and it does not contain any duplicate values, but a tuple can contain duplicate values and it is indexed as well. So we can declare duplicate values in tuples, but not in the set. So this was a brief discussion about variables and data types, guys. If you want a detailed discussion about variables and data types, you can check a video on Edureka platform where we have discussed variables and data types in detail, where we have also discussed various operations that you can perform on a data type. Moving on to the different types of operators that we have in Python. So here is a list of all the operators that we have in Python. So first of all, we have arithmetic operators, then we have assignment operators, comparison operators, logical operators, then we have membership operators, identity operators, and bitwise operators. So we will be discussing all of these operators in detail. So let's talk about arithmetic operators. Arithmetic operators are nothing but the operators that are used to perform arithmetic operations between variables or two values. So these are the arithmetic operator symbols that we use in Python. So we have addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. So let's take it up to Jupyter Notebook to understand the concept of arithmetic operators. So let's say I have two variables, x, I'm going to give this value as 10, and then I have one more variable, let's say y, I'll give it a value, let's say 20. Now to understand the concept of arithmetic operators, what I'm going to do is, first of all, I'll try to perform addition between these two variables. So I'll just write plus over here, and when I execute this, I'm going to get the addition as my output. Now to perform subtraction, I'm going to use the subtraction operator, and it is going to give me the value as the subtraction over here. Similarly, I can perform multiplication. Then I can also perform exponentiation. So I'll use two asterisks instead of one for exponentiation. It is that easy in Python, guys. Now we will perform division over here. So it is going to give me the value of the division. Now when I do the floor division, I'm going to get the value over here as well. One more operator is left, that is the modulus. So I'll try to perform modulus as well. So it is going to give me the value, that is the remainder. So this was all about arithmetic operators, guys. So these are all the symbols that we can use for various purposes like addition, subtraction, multiplication, division, etc. I hope you are clear with the concept of arithmetic operators. Now let's try to understand the next operator that we have, which is assignment operators. So you can imagine what an assignment operator is by the name itself, that is assignment. So we use the assignment operators to assign values to a variable or any value that we have in Python, right? So we have assignment operators like is equal to, then we have plus is equal to. So all these symbols we have, let's try to understand what all these are used for. For example, let's say we have a variable x which has a value 100. Now when I write this x plus is equal to 10, it is going to mean the same as x is equal to x plus 10. Similarly, we can write x minus is equal to, multiplication is equal to, division is equal to, or exponentiation is equal to. Now let's try to understand these operators or the assignment operators in Jupyter Notebook. So first of all, we have is equal to as our first assignment operator. So I'll have 1, let's say I have x. So I have not assigned any value to this. Let's say what happens. Okay, let's try one more variable. I'll write this. So it is showing me a name error, which is saying name A is not defined because I have not assigned a value to it. So in Python, until you assign a value to a variable, it is not going to be declared in Python. So now when I give the value to this variable, let's say I'll write 5 over here, it is not showing any error, which means I have assigned a value to this variable. Now let's try to understand other assignment operators. Let's see. So what does plus is equal to mean in Python? So when I write this, what should be the output, guys? So let's try to understand this. So when I print A, I get the value as 10. So why I'm getting this value? Because I have assigned the value 5 over here. Then I write one more assignment operator, that is plus is equal to 5. So what is going to happen over here is it is going to be same as A is equal to A plus 5. So we have 5 over here and we have added 5 more to this statement, which means we are getting the result as 10 over here. Now let's try to understand other assignment operators as well. So let's say exponentiation is equal to 5. So let's see what the output will be. So when I print this, I'm getting the exponentiation to the value of 5. Since a is equal to 10 and we are doing the exponentiation until 5 digits, so we are getting the output as 100,000. So this was all about assignment operators. Similarly, we can do the division is equal to, then we have minus is equal to. So these are all the assignment operators that we have in Python. Now let's talk about the next operator that we have, which is comparison operator. So comparison operators are nothing but the operators that we are using to compare two values or objects, right? So we have comparison operators like equal, not equal, greater than, less than, greater than or equal to, and then we have less than or equal to as well. So let's try to take an example over here. So when I use the equal operator, I'm going to write the statement as just I have written over here, x is equal to y. So when I'm using the comparison operator, I'm actually using double equal to. So this is the basic difference between assignment operator and comparison operator. So let's take it up to Jupyter Notebook to understand these comparison operators, guys. So let's say I have two variables, value is equal to 10 and number is equal to 20. So to understand the comparison operators, let me take one more variable. I'll say this will be our Boolean variable. So what I'm going to do is I'll write val is equal to number 1. What I'm checking is or comparing these two values. So what exactly I'm doing is comparing these two variables or values that we have, that is val and number 1. So when I print this compare variable, what I'm going to get is either true or false. So it is going to be false because value is not equal to number. So I can do the similar thing. I can check whether it is greater than, or I can check if it is less than. So when I write 10 over here, so I can similarly check if it is greater than or equal to. I can check if it is less than or equal to. So these are the comparison operators that we have in Python, which we can use to compare two values or two objects. Now let's try to understand the next operator that we have, which is the logical operators. So logical operators are used to combine conditional statements. So what are the conditional statements that we have in Python? So let's briefly talk about conditional statement, guys. So mainly we have three conditional statements in Python. We have an if statement, then we have an else if statement, and we have an else statement. So I'll give you an example for better understanding. So for these two variables only, I'll write if val is equal to number 1, print equal. Else if val is greater than number 1, print greater. Else print smaller. So what happened here is, guys, first of all, the execution will go to the if statement. It will check this condition. If this statement is true, it is going to print this value. If this is false, it is going to move to the next statement. That is the else if statement that we have over here. It is going to check this condition. If it is true, it is going to print this statement. Or if this condition is false, it is going to jump to the next statement, that is the else statement. And I'll give one more condition. So if all of these conditions are false, it is going to jump to this statement and it is going to print not there over here. If all of these conditions are false, it is going to jump to the next statement that we are going to have in the program. But I have not written any other statements, so it is going to end the execution over here only. So this is a basic example using the conditional statements. Now that we are done discussing conditional statements, let's talk about logical operators. So I have told you logical operators are used to combine conditional statements. So what exactly are the logical operators? So we have a logical AND, we have logical or we have a logical NOT as well. By looking at the example, let's say we have two conditions over here. We have x is greater than 5 and then we have x is greater than 10. So let's try to understand these logical operators in Jupyter Notebook. Now let's say I have two statements. I'll write x is equal to 10, and what I'm going to do is I'm going to check if x is greater than 10. I'll write AND, which is my logical AND operator, and I'll write x is greater than 5. So what is going to happen if I use the logical AND operator? If both of these statements are true, it is going to give the result as true. But if one of these statements is false, it is going to give me the value or the output as false. So let's see what happens if I execute this statement. I'm getting false because one of these statements is false. Now when I write instead of 10, if I write 8 over here, let's see what happens. Since both of these statements are true, it is going to give me the output as true. Now instead of AND operator, if I use the logical OR operator, let's see what is going to happen. It is showing me that it is true, because when we are using the logical OR operator, only one of these statements has to be true, the output will be true. But what happens if both of these statements are false? It is showing me the value that is false. But let's see what happens if both of these statements are true. I'm getting true as well. So one of the statements has to be true when we are using the OR operator. Now talking about logical NOT operator, what I'm going to do is I'll write NOT in the beginning. Now I'll specify the condition. Let's say x is greater than 10 and x is greater than 5. This is the same statement that we have used before, and for this we have got the output as false. So let's see when we use the logical NOT operator, what is going to be the output. I'm getting true as the output here because this statement is negated over here using the NOT operator, and we are getting the opposite value that we should be getting for this statement. So this is the purpose which fulfills by using the NOT operator or the logical NOT operator that we have in Python. So now that we are done with logical operators as well, let's try to understand what are identity operators. So identity operators are used to compare objects. Now you must be wondering, what are objects here? So everything in Python is actually an object. So we can use the data types as objects as well. So let's try to understand what are the identity operators in Python. So we have is and we have is not. So these are the identity operators. So what is does is it returns true if both the variables are same object. For example, let's try to do this in Jupyter Notebook. So what I'll do is I'll take, let's say, a list. I'll give it some values, let's say 10, 20 and 30. I'll take one more list, give it the same values, let's say 10, 20 and 30, and I'll write x is equal to list 1. So when I use the identity operators, let's say if I write x is list 1, let's see what is the output that I'm going to get. I'm getting true because x is actually the same object as list 1. Now let's try to write list 1 is list 2. Even though when we have used the same values in list 1 and list 2, let's see what the output will be. It is false because these are not the same objects, right? Similarly, I can use list 1 is not list 2. So here I'm going to get the output as true because list 1 is not exactly list 2. Even though we have the same values, it is not going to be the same object. So this is the concept about the identity operators. Now let's talk about the next one that we have is membership operators in Python. So membership operators are used to check if a sequence is present in an object or not. Now to understand the difference between an identity and a membership operator, okay, let's first understand what are the operators in membership operator. We have in and then we have not in. So it is going to return true if a sequence with the specified value is present in the object, and it will return true if the sequence is not present. So let's do this in Jupyter Notebook. We have already specified these objects. So let's try to do if x in list 1. Let's see what happens. It is going to show me that it is false because we have no values in x. So when I do the same thing with list 1 in list 2, now you see we have the same values over here. Let's see what the output will be. It is false again. Okay, let me do one thing. Now to check a particular value or a particular sequence, what I'm going to write is I'll check if 10 in list 1. So it is going to check if this is going to be present over here or not. It is showing me that it is true. So what if I write like this, 10, 20, 30 in list 2? It is false. So this is the basic difference between is, that is an identity operator, and membership operators. So when I write, let's say, it is going to check if this is present in the sequence or not. It is showing false because it is not there. But what if I add this value over here? Let's say, now when I execute the same statement, I'm getting true because this sequence is actually present in the object. Now to understand the difference between is equal to and the identity operator, let's see what is going to happen. What if I write list 1 is equal to list 2? It is showing false. I have made a change over here. So I'll do this once again. So when I print this, it is showing that it is true. But instead of is equal to, if I write is over here, it is going to show me false because these are two different objects. So this is the basic concept of identity and membership operators, guys. Now let's understand bitwise operators. So bitwise operators are used to compare binary values or binary numbers. So this is a rather difficult concept, guys. So I'll be telling you about what are binary numbers first, and then we'll be moving on to the bitwise operators that we have in Python. So these are the bitwise operators like bitwise and, bitwise or. So these are the symbols used for these operators, guys. So this is actually what happens when we are using these operators. So let's try to understand bitwise AND operator first in Jupyter Notebook. So what I'm going to do is I'll just write 10 and 12. So what is going to happen over here? Let's say it is showing me the output as 8, but it is not clear why we are getting this output, right? So let's understand what 10 is in binary numbers. So when I write 10 in binary numbers, it is going to be 1010, and similarly for 12 it is going to be 1100. Now when I use the logical AND operator, what it's going to do is if both the bits are 1, it is going to be 1. So in this case only first bit is 1 over here, so the output will be 1000, and if we convert this to decimal, it is going to be the number 8. So this is the concept between the binary numbers, guys. Similarly, I can use 10 or 12. So what is happening here is I have these values, let's say 1010 for 10 and 1100 for 12. Now looking at first bits here, that is 00, it is going to be 1. So all of these bits in the output will be 1111, which is exactly is equal to 14. So this is the concept of using the bitwise operators, where we are using the values as binary numbers. We are comparing the binary numbers. Now let's talk about left shift and right shift, guys. So this is what I write for doing the right shift. So 10 in binary numbers is 1010. So when I right shift these two bits, I'm going to be left with 10. And when I convert this to binary, I'm going to get the value as 2. So this is the concept of right shift, guys. Now let's try to understand left shift. So when I write this, I'm going to get the value as 40. Now let's try to understand how I am getting this value. So 10, if I write it in binary, is going to be 1010. So when I do the left shift, what is going to happen is it is going to shift two values, and I'm going to get the value as 101000. So what is happening here? If I convert this binary number to decimal, I'm going to get the value as 40. So this is why I'm getting the value 40 over here. So this is the concept of bitwise operators, guys. I hope you are clear with the concept of bitwise operators. It is a bit complicated because we are using the binary numbers. Even though I'm telling you these binary numbers, you need not mention them while using the operators. For example, for these bitwise operators, all these are written over here. Let's say if you are using the bitwise AND operator, it will set each bit to 1 if both bits are 1, as I've shown you. And then for bitwise OR operator, it is going to be 1 if one of the bits is 1. So similarly for XOR, it will set each bit to 1 if only one of the bits is 1. And then we have bitwise NOT operator, which is going to invert all bits. Let's say if we have all bits that is 1, it is going to convert all those bits to 0. And then I've told you about left shift and right shift as well. So this is about operators in Python, guys. Now that we have come to the end of the session, if you have any questions, you can put them in the comment section and our team will get back to you as soon as possible.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!